Hello and welcome to another video. In this one we're going to be looking at our cosine law. From our last video what we were looking at was the sine law, and so first here we got a problem where it says solve for x, and what we're going to try to use, because the only thing we know right now is the sine law, and we're going to see what happens. So we have these two sides here, 4 and 5, and we got the angle in between. So I knew with the sine law, if I could get a matching pair like this, that would be good. Those two go together, and then I could try to find some other matching pair, say like those two, or if I didn't want to use that one, I could use this as a matching pair, but I don't know what this angle is here. And for me to use that pair, I have to know that angle. So you kind of run into a problem where the sine law can't be used. So sine law can't be used, and that's where the cosine law comes into play. So looking at our cosine law, we're going to do the same type of thing. We're going to look at the law and when it's going to be used, and then we're going to do the proof for how to come up with it, and then we're going to do some examples using the cosine law. So it says here at the top, for cosine laws for solving triangles, if the given measurements are, so if you're given one of these two cases, so if you're given all three sides, so I'm just going to put that down here. Let's say you got check mark, check mark, check mark. You have all of those. Or the other situation is you're given two sides with the angle in between. So you could have, say, this side, and then the angle in between. So it's either this scenario or the other scenario. Either of those scenarios, you're going to use the cosine law. If you had either of these scenarios, as we just kind of found with that first example we looked at, it is not possible to solve a triangle using the sine law. So can't be done with sine law, got to use cosine law. So what is the cosine law? That is this right here. Okay, so there's our cosine law. A squared equals b squared plus c squared minus 2bc times cos of a. So there's a multiplication in between there. Okay, that is multiply in between the c and the cos a. Okay, and then it says, note, when given the measures of three sides, always calculate the largest angle first. And the largest angle will be across from the largest side. That's just so you know that the other angles you are going to find, they're going to have to be smaller, and they're going to have to go with those smaller sides. You don't have to do the largest first. It's just kind of a hint. So let's get into our proof here now. And again, I know I said before in the previous video with sine law, proofs are difficult. If you have a hard time with the proofs, just try to watch the video over again. I don't expect you to get it in the first try. So what we're going to do with this one is we're going to, again, label our triangle just kind of generally. So we're going to call this A, B, and C. And we're going to name across from our sides, this is going to be side A, across from B is B, across from C is C. And then we're going to do the same kind of thing where we split apart our triangle into two 90-degree triangles, and we're going to call that there the height. Okay, so what we're going to do with this one, because if you look at the cosine law, you see this a squared equals b squared plus c squared, and that kind of resembles something of Pythagorean theorem. So we're going to use a little bit of Pythagorean theorem, and we're going to use the cos ratio as well, and it'll kind of work some magic, and we'll come up with the proof. So a couple other things I'm just going to add. This is going to be triangle 1. This is going to be triangle 2, just to kind of separate the two apart from each other. And this part right here, we're going to call x. And this part on triangle 2, we're going to call that y. So in triangle 1, we're going to look at that one here first. And I'm just going to divide my work. I'm going to put triangle 2 work over on this side. So in triangle 1, what we're going to do first is we're going to use Pythagorean theorem. So I'm going to do a squared plus b squared will equal c squared, the longest side. So that was x squared plus h squared equals c squared. And then what I'm going to do, kind of like when we did the sine law, is we're going to try to solve for h. So to get h by itself, I'm going to minus x squared from both sides, minus x squared. X squareds will cancel. And then I have h squared equals c squared minus x squared. Okay, then I'm going to do pretty much the same thing for triangle number 2. So that's going to be a squared plus b squared equals c squared, the hypotenuse side there. Okay, so that was y squared plus h squared equals the hypotenuse squared, which that was b, so b squared. And again, I'm going to try to get the h by itself, so subtract both sides by y squared. And those y squareds are going to cancel. So now I just have h squared equals b squared minus y squared. Now that I know what h squared is in both of these, I can take these two things and I can set them equal. Just going to move up this middle line here. So I have c squared minus x squared on this side, that was h squared, and on the other side I have b squared minus y squared, that was also h squared. So I can set these two sides equal. Again, that was using that transitive property that we looked at in the last video. So now that we got this, I'm going to try to get that c squared by itself. I'm going to try to get rid of that minus x squared. So to do that, add x squared onto both sides. X squareds cancel out. And then I have c squared equals x squared plus a b squared minus a y squared. Now the x and the y, if I had my triangle here, you're never going to be given part of a side, like this y part or this x part. So what we need to do is we need to get rid of the x and get rid of the y. And to do that, we're going to try to use it in terms of either a, b, or c. So to get rid of the x here first, what I could say is this part x, it's equal to this whole side, but get rid of this y piece. So this whole side is a, and then get rid of the y piece. So x is equal to a minus the y part. So I'm just going to write that. X is equal to a minus y. And I'm going to substitute and change that down into here. So c squared equals, and then x is going to change into that a minus y. So a minus y squared plus b squared minus y squared. I'm going to worry about getting rid of the y squared later. Okay, so let's take what we got and let's start to simplify this. So I'm going to FOIL out this part here. A minus y squared is a minus y times a minus y. So I'm just going to do that here. A minus y times a minus y. So I'm going to have a times a, that's going to give me an a squared. I'm going to have an a times a minus y, that's going to give me a minus ay. Just going to write it there for now. And I'm going to have this y times that a, that's another minus ay. So those two I can actually put together. So that's going to give me minus 2ay. And then lastly, I have a minus y times a minus y, that's going to be positive y squared. Okay, and then just write out the b squared minus y squared. So plus b squared minus y squared. And now I can see I got this y squared and this y squared. Those are opposites, so if I put them together, those are just going to cancel out. So those are gone. So let's rewrite what we have left over now. So we've gotten that. The only thing we still got to get rid of, we got to get rid of that y. Okay, and to get rid of the y, if I look up at my triangle here, I'm going to look from this corner and I'm going to try to relate something in terms of that y. Okay, so from that corner, y is adjacent. So I want to use something that has adjacent in it. And I know the cosine ratio is adjacent over hypotenuse. So I can use that. So I'm going to have cosine is actually equal to, adjacent is y, and then the hypotenuse is b right there. So I got that. And then if I multiplied on both sides by b, those b's are going to cancel. And so I have y on that side is equal to b cos theta. So I know y is equal to b cos theta. So I'm going to change that down below here. Y is going to change into b cos theta. I'm also in this step, I'm just going to write the b squared here. I'm just going to change the order. And then we have minus 2a, and then the y changes into b cos c. And again, it was angle C. I didn't write that up top here, but we were looking from angle C. I just forgot to fill in the angle, so I'll do that. That was angle C. Okay, so we've gotten that. Now, if I look at that, that is now the cosine law. And a big thing to note with your cosine law is that whatever letter this is here, all the way across on the other side, whatever that angle is, those have to be the same letter. So if this was an A, then this would have to be an A. They always have to be the same letter, and then these two letters would be a B, and this would be a C, this would be a B, and this would be a C. Okay, but these two, those always have to be the exact same letter. Okay, so now that we're finished with our proof, again, just put that little box in the corner. That just signifies the proof is complete and you're finished. So from there we can move on to our first example. So in this one it says solve for f. So we're going to be finding this right here, that side. Now I'm given a side, an angle, and then another side. Okay, so that right there, that is the kind of SAS scenario, side, angle, side, and that's when you're going to use the cosine law. And what it allows you to do is it allows you to find the side across from that middle angle. So I'm going to be able to find f. So let's write out our formula and then we're going to fill it in. So we're going to have f squared is equal to, and then my two other letters were a d, so d squared, plus e squared minus 2 times d times e times cos of f. Okay, these two letters, remember, f and f, they're kind of on the outside or the perimeter. Those have to be the exact same letter always. These ones in here are just the other two letters, and the order of them, it actually doesn't matter. Okay, so now that we got this, let's just start to fill it in. So f squared equals the d, that is this, that's 25. So we got 25 squared plus e, that's that side across from the angle e. So that's 30 squared minus 2 times d, which we said was 25, times e was 30, times cos of f, and f is 40 degrees. Okay, and then we can just start to simplify this. So 25 squared is 625. 30 squared is 900, and then if I do this multiplication in there, 2 times 25 times 30, that gives me 1500. So we got that. And then our next step, we can put this whole thing into our calculator, and when we do that, you're going to get 375.933 ... There's more decimals after that. And then what we need to do, we got to get rid of this square. So to do that, take square root, square and square root cancel. And so I got just the f, and then the square root of that 375 number, we get 19.3890 and some other decimals. Again, make sure you don't round as you're going through any of these steps. Round in the very last step. And it didn't say what we needed to round to, so we're just going to round to the nearest tenth. So we're going to get 19 point, and then this 8 will round up to 3, so we get 19.4. And our units, they were meters for the sides. So that one is done. We can move on to our next one. It says, if you own a triangular plot of land and would like to fence it all, how many meters of fencing is required if you've determined the following measurements? So we have to fence all the way around this. I already know 2 of them. I just got to find this one, which that is side A. So A is a question mark. And then once I have those, I know that the total amount of fencing that I'm going to need is just the perimeter. So my perimeter is what I want to find at the end, and that's going to be 28 meters plus 40 meters plus whatever A is. So we'll do that at the end once we find A. So to find A, I already can see I got this side, I got this angle, and then I got this side. So again, that's that side angle side scenario. So I can use my cosine law, and it's going to help me find the side across from the middle angle. So we got A squared equals B squared plus C squared minus 2bc times the cosine of A. So now we just got to fill in our information. So A squared equals B squared. Again, this was B and that was C. So B squared, we got 28 squared plus C, that's 40 squared, minus 2 times B, which is 28, times C, that was 40, times the cosine of A, which is 32 degrees. Okay, and then slowly start to simplify this. So 28 squared plus 40 squared minus all that. When I put this all into my calculator, that's going to give me 484.37. And then some more decimals. If you need to do that in more than one step, do it in more than one step. Okay, and then get rid of the square by taking the square root. So square root cancel. And we get A is equal to 22.0084. Okay, and then if I round that to the nearest whole, because if we were going to be buying our perimeter fencing, you're probably not going to go in and ask for, say, a part of a meter. You might even round up possibly to make sure you got enough, but we're just going to round that because it's so close to 22. So it's 22 meters. So total, our perimeter, it was 28 meters plus 40 meters plus this 22 meters we just found. And when we add that all up, you're going to get 90 meters. So there's how much fencing we would need to buy. Okay, on to our next one. So in the first two, all we did was we found sides. Now in these next ones, what we're going to do is we're going to find angles. So it says using the cosine law to solve for angles. So if you know all 3 sides of a triangle, the cosine law can be arranged to solve for any of the unknown angles. So again, that was if you had any 3 sides, you can find any angle. So we're going to take this and we're going to rearrange it to solve for angle A. So to isolate A, we got a minus b squared and minus c squared from both sides. And we got to do that on this other side. So I'm going to have these canceling. And then I'll just have a squared minus b squared minus c squared on the left. That equals minus 2bc times cos of A. To get rid of this timesing by minus 2bc, we're going to have to do the opposite. We're going to have to divide by minus 2bc, and then do that on the other side, minus 2bc. And on the right, all of this cancel. So on the right hand side, all that's left over is we have cos of A, and on the left we have a squared minus b squared minus c squared, all divided by minus 2bc. Okay, then if we wanted to clean this up just a little bit, we could divide each of these terms by the negative to get rid of this negative. So that's going to get divided, it's going to become a minus, this is going to then become a plus, and that's going to become a plus. So let's just write that out. And I'm going to change the order just because the b squared and the c squared became positive and the a squared became minus. So I'm going to put it like that. And that equaled cosine of A. So that is my cosine law, and that is on our formula sheet. So this is what you would want to use if you were finding an angle. It's going to be a lot easier because it's already rearranged really nicely. The one thing to note, whatever angle you are finding, that is the one thing you are minusing in the top here. Okay, so if you're finding A, angle A, you're minusing A squared, and everything else is positive. Okay, so let's use that now to find angle A in this next one. So angle A, that is right here, so that's our question mark, and that is across from this 11. So again, in our formula, if I'm finding A, that's got to be the one across from it. So this is angle A, and this is side A. So let's just write out our formula. Cos of A is equal to B squared plus C squared minus A squared, all being divided by 2BC. So cos of A, so we're just filling it in now. B squared, I'm going to just write some letters on here. I'm going to say that this is my B and that is my C. So B squared, that's 9 squared, plus C squared, that's 7 squared. And it wouldn't matter which one I said was B or C. I could flip it, I'll still get the same thing. And then minus A squared, that was 11. All divided by 2 times B, which was 9, times C, which was 7. Okay, if we simplify the top of that, the 9 squared plus 7 squared minus 11 squared, you're going to get 9. If you simplify the denominator there, you're going to get 126. Okay, and then to get rid of this cos, we have to do the opposite of cos. We got to take cos inverse. So cos inverse this side, and cos inverse this side. So cos inverse cancel, and we're only left with A equals cos inverse of 9 over 126. Okay, and then we're going to put that in our calculator. So go to cos inverse, so that's second cos, and then we're going to click 9 divided by 126, and then make sure you do your closing bracket. If you don't do your closing bracket, depending on your calculator, you might not get it right. And again, make sure your mode have to be in degree mode. And then click enter, and we get 85.9039. And then rounding this to the nearest degree. Usually for angles, we like to round to the nearest degree and have no decimals. You're going to get 80, that'll round up, so we get 86 degrees. So that is it for examples. That was our last one. Just going to write our homework questions here now at the bottom. And just a note, for 4 to 7, you're only doing part A only.